From the studios of Way Happy, this is Mr. Meyer, and I am doing a section on log properties. And I'm at Twitter, and I'm showing you that Miss Avila of her AP Stats class even tweeted from Chapter 4, apparently, don't forget your log properties. You better be real good with them. And guess what we are doing? That is right, folks. 3-4 properties of logs. And that is exactly what she's talking about. There are 3 properties of logs that you need to know. One is called the product rule, one is called the quotient rule, and one is called the power rule. Now, what is the product rule? The product rule just says one simple thing, that if you have the log of some things multiplied together, I don't care what they are, as long as there's the word log and they're multiplied together, you can break that apart as separate logs of each one through the magic of addition. And since logs have something to do with exponents, you could research on why that is. But you break them apart with addition. So multiplication can turn into addition, and the other way around. You have a bunch of logs that are added together, and you're like, man, I wish I could condense that somehow. You can condense it down to multiplication. Now, the quotient rule says, all right, if you got logs that are divided 4 over x, then feel free to subtract those 2 logs as 2 separate logs, right? Notice before I had just the word log once, but now I have the word log twice, because that's how many terms, I guess, not really terms, but how many things you could say were behind the word log. And like before, I had 3 things, and then there was 3 logs separately. Also can go the other way. You see some logs subtracted, 2 logs. They each have their own log. You could then change them to division. And last but not least, everybody's favorite, the power rule, and the most helpful rule probably ever, is that if you have an exponent, you can bring that exponent out in front of the word log. Super nice to have. So with those 3 properties, and Miss Avila and I telling you how important they are, I want you to now do these 3 examples. Go. All right, let me help you out here because it's probably not too spooky, but notice I see a bunch of multiplied logs. So I'm going to definitely break that apart because it says expanded. I'm going to break it apart to addition. So we got log of 8 is one thing. We got log of x squared, so log of x squared. And we got log of y cubed. Boom, just broke them all apart. How you like me now, right? And then I could even pull the exponents out front. Now, sometimes I will see people take the log of 8 and change it to 2 cubed. So don't be surprised, but I'm not going to, but you could. And maybe I'll show it underneath. Log of 8 plus 2 logs of x plus 3 logs of y. And like I said, I could see this one being 2 cubed would be 3 logs of 2 plus 2 logs of x plus 3 logs of y. And now you have a gorgeous expanded problem that I don't think we could expand any farther. So I'm feeling good. All right, what about natural logs? Work the same way as logs. So again, here I see a division problem. So I would change that to the natural log of the square root of x minus 4 minus the natural log of x. So I've now cleaned up the division. We all know square root is actually log to the 1/2, or I'm sorry, x minus 4 to the 1/2. So I might change that, x minus 4 to the 1/2 minus ln of x. And then I can bring that half out front. So I got a 1/2 ln of x minus 4 minus the ln of x. And now be super careful. I see a subtraction there, but it's not a log minus a log. It's actually just ln of x minus 4. And I can't break that apart. It's not multiplied. And so therefore I can't break it apart. All right. I said, what about going the other way? Because that's always fun too. What if somebody asks you to condense something? So look at example 3, where I'm going to try to condense into one single log. So here we work a little backwards. First, I'm going to do power rule. So I see the 6 can go up. So that would be the ln of x to the 6th minus ln of, now both of them get that 3 because they're in parentheses. Now I see a little bit of subtraction going on here. So I will take care of that. Ln of x to the 6th over xy cubed. And I think I can still clean that up even more by saying ln of x to the 6th over x to the 3rd y to the 3rd. And even more, ln of x to the 3rd. Whoa, where'd that x come from? ln of x to the third over y to the third. And so there you see a nice condensed log down to one log. It started off as 2 logs and a bunch of gobbledygook, and I condensed it. Now, this is going to come in handy in calculus when you have to actually expand problems. Usually it's too complicated as one log, and it's nicer to work it back and get it down into simpler things. So that's why expanding and condensing is really important. So we want to make sure we spend some time and we can handle expanding and condensing easily. Now, what else do you want to know? I got a couple here that I just wanted you to decide which of the following are true. So look at the first one. Does the log of x plus 3, does that break apart to log x plus log 3? No, you are correct, because it is multiplication that changes to addition, not addition changing to addition. It's not a distributive property or anything like that. So nope, that is not true. There's multiplication, sweet. So that next one, I see multiplication, so I know they're going to add it. Oh, wait, no, they just moved the 5 out front. That's not true. A 5 out front is an exponent, so that's no good. Oh, look at that one. That's beautiful. Log x over 6, right? What does that change to? Subtraction. What did they do making it a fraction? That's crazy. Gets very confused with something that's coming up after the questions. So realize that this is a very common mistake, but not true. Oh, look at that. Log of 2x in absolute values. That would change to addition, and oh my gosh, they actually did. It did change to log of 2 plus log of x. Beautiful. Don't need absolute value bars around the 2 because it's already positive, so just need them around the x. So that one is actually good. And the last one, ln of x squared, that means 2 out front, so that's like an ln of x plus an ln of x. Oh, no, no, not times. So no good. So there was 4 bad and 1 good. Nice work. Let's give you a question, and I'll be right back after this short break. All right. Excellent work. And you know what I say to that? Go, Mats, go. That's right. Little Granada spirit. Keep up the good work. All right. What about are we talking about now? We're talking about change of base formula. And change of base formula is, what if somebody gives you a problem like down here that you need a calculator for and you can't solve? So how the heck would you do it? Or maybe I'll want it in calculator ready form, which means do the work so I can just type in a calculator if it's on a non-calculated test. And in the past, it was pretty hard to do. And here is the change of base formula right here. It says, I don't care what base you're in. As long as you do log of x over log of b, you are going to get the answer, assuming that you use some common base. Now, most of us would use log base 10, because our calculator has a log base 10 button, or I could use a natural log button. So what I'm talking about is this. Say I have log base 3 of 7. I don't know what that is. I know 3 squared is 9, so it's a little less than 2. But what I could actually do on my calculator back in the day was that I could hit log 7, and I would use base 10, and because my calculator had a base 10 button, and over log 3. And heck, I'm going to even fire up Sheila and show you that you can see what my answer is. So I know it's somewhere less than 2, right? So I would just go log 7 divided by, and maybe I should use the fraction button, but log 3, and that's called change of base formula. I changed it to base 10, and the answer is 1.77. So I'm very nice. Now, a little heads up, your calculators are a little fancier these days, and you guys have right here, you have the F, I think it's either 2 or 3 button. I'll have to check. So alpha F2, nailed it. If you look at alpha F2, if you happen to have the new operating system, look at number 5 right there. It's called log base. And what have they done? They've ruined the change of base formula, kind of. If you hit number 5, it will ask you what is the base. So it was base 3, and what are you trying to find the log of? 7. And if I hit enter, it does change a base formula for me. So a little heads up, your calculators are smarter now than they were. So change of base, not a big deal. You can use, the neatest thing about it is you can change to any base you want. Like if I wanted base 10 because of my calculator, or ln, but what if somebody asked you to change it to base 3, or base 7 or something? I could still do that too. I could just do log 7 of 7 over log 7 of 3. And so don't be freaked out that I might ask you to change it to a weird base, just so I know that you know the change of base formula. So make sure you got that change of base formula and it doesn't scare you. Biggest thing I can tell you is the base should always be in the base of the fraction. So make sure you got it going the right way. So example right here, this would just be log 17 over log 4. Notice the base number was in the base of the fraction, and you got yourself done. This is calculator ready form. So if this was a no calc, that would be your answer. If it was a calculator, I would just say type it in and give me the decimal. Now, without a calculator, what are you going to do? Same thing. Look at that gross problem, but that's just log base 2 over log a half, right? And so feeling good and happy. Maybe it would even be better to have done log base 2's, because I could do log 2 of 2 and log 2 of a half. Now, why would that be helpful? Because I know what log 2 of 2 is, that's 1, and I know what log 2 of a half is, isn't that negative 1? So therefore, I could tell you that this answer is negative 1. This is just a fancy way of saying negative 1. And some of you might have known that already. You're like, wait, half to the negative 1 power is 2. So we knew that. Well, look, we used change of base and we got it to work too. Isn't that awesome? Math, when it works all the way across because you understand it, it just makes total sense. Gosh, I love it. Anyway, here's probably one of the most confusing things, but the most fun things, I think, is that therefore, with change of base formula, any log function with base whatever can be a graph of a natural log, or really a graph of a log base 10, whichever one you want to pick, because of change of base formula. And it's really hidden right here in these steps. You have log of anything. You can do change of base formula. Once you do change of base formula, you can break that apart as to 1 over, whatever the ln of b is times ln of x. And look, there's the regular old log graph, and here's like a little vertical stretch or compression, whichever one you want to call it. And so that is kind of fascinating that you can graph any log base as long as you know this little change of base formula. So look at this. If I wanted to talk about log 5 of x, what would I do? I need to do it in terms of natural logs, no big deal. So first thing I would do is I would say, all right, log 5 of x, that's the same thing as the natural log of x over the natural log of 5. And that I can break apart as 1 over the natural log of 5 times the natural log of x. We know this graph, right? That's this guy. Boom, and you do a little asymptote and right? There it is. But what's happening to that graph? Well, this is happening to it. It is getting a compression or a stretch, depending on what that is. Well, this is e to what power is 1.5. So that's a little bigger than 1. So this is like 1 over 1.2 or something like that, right? So this is definitely a compression. So this is a vertical compression of 1 over ln of 5. So on a natural log graph. So if you took a natural log graph and you added this compression, you would definitely have our beautiful answer. Isn't that great? So you can compare it to any natural log graph, no matter what the log's base is. All right, here's your last one. Describe that transformation. So again, same exact thing. I'm going to go, all right, ln of x over ln of 1/4. Oh, yuck. Oh my gosh, division. In the world of logs, that changes to something, right? I could change that to ln of x over ln of 1 minus ln of 4. Oh, that's so much better. Why? Because do you happen to know the natural log of 1? Wait, you know the log of 1 of any base. It's always 0. So that's ln of x over 0 minus ln of 4. Or let's make that look a little prettier, ln of x over negative ln of 4. Holy macaroni. Now, how does that relate to an ln of x graph? Well, 1 over ln of 4, oops, forgot my negative, times the ln of x. So there's your ln of x graph, and it looks like it's getting this going to it, right? Looks like another compression and flipped over the x-axis. So I would say you have an x-axis reflection, and I would say that you have a vertical compression of 1 over ln of 4, and do that to an ln of x graph, and you have your answer. That's it. Nice work. Stay happy, and I'll see you tomorrow. Go, Mats, go.